4.5 intermolecular forces. So intermolecular forces means when you have a substance, there will be a attraction between their own molecule. For example, water, you have the molecule of the water, they attract each other. That's why they are in a liquid form, right? So intermolecular forces is different than the bound forces. Make sure you know it. The intermolecular force is much more weaker than covalent bonds. As an approximate comparison, the covalent bond is 100, then intermolecular forces are 0.001 to 15. So we're talking about dipole forces. So dipole forces, when you have a polar molecule, like what? Like HCl, we did talk about HCl. It's like a magnet. Electrons spend more time around Cl than H. Right? It has a partially positive side and partially negative side. They just put it in this way, in this form. So we have a negative and we have a positive. So if you have like a one HCl here and another HCl here, the positive side of one HCl will attract the negative side of another HCl. That is dipole force. So dipole force is coming from polarity of molecule. Now the next intermolecular force is a London force. You know, any molecule has electron and proton, right? So let's say this is a molecule that you have a nucleus, which just has positive charge, and you have electrons just floating around. If you have one molecule, the positive charge, the nucleus of one molecule attract the electron of the other molecule. And same way, the electron of this will attract the nucleus of the other one. So these interactions of London force is coming from the electrons and protons inside the molecule, which was much more weaker than dipole force. Okay, so looking at this, we have CH4, SiH4, GH4, SNH4. All of that is non-polar. You want to compare the boiling point of that. The first one has 10 electrons. Here is 18, 36, and 54. So the number of electrons will increase as go down. And the boiling point increasing, of course, because the London force is the force between them. There are non-polar, so the only that forces is between them is going to be London force, which is depends on the electron and proton. So more electron proton you have means the London force attraction between the molecule is going to be bigger. So 54 is bigger, so that's why you have a higher boiling point for SNH4. So the number of electrons and proton is much more bigger than the others. Okay, let's just look at that. CH4, C2H6, C3H8, and C4H10. All of them is non-polar, so we have to talk about London force. As you see, the London force is going to increase as the number of electron proton increase. That's why C4H10 going to have a higher boiling point. C-butane has higher boiling point. The next one, Br2 and ICl. So Br2 is non-polar, ICl is polar. Of course, both of them will, of course, has the same number of electrons. How do I know? Just look at the Br. See the table, it will give you the number of electron and proton for them. Count it down, 70, ICl is named 70. But ICl is polar, that's why the dipole force is there, right? So that's why it has a higher boiling point. The attraction between the molecule is bigger, means is not, you cannot easily take them apart, right? So you need to give them more energy. So you need to boil them, you need more temperature to break them apart. That's why the boiling point is much more higher. So to do that, you can question number 1 and question number 3. So hydrogen bonding. For hydrogen bond, when you have a nitrogen, oxygen, and fluorine, so you have these three bounded with hydrogen. Then you have hydrogen bonding. I'm gonna give you an example here. Like NH3. NH3, we have N bounded with hydrogen. So H has a partial, is a polar, right? Polar bond. Has a partial negative, positive charge. Will attract to the N of the other molecule. So between the hydrogen and this N will be hydrogen bonding. H2O, between the hydrogen and the oxygen of the other molecule, there is hydrogen bonding. HF, between hydrogen and the F of the other molecule, that will be hydrogen bonding. Hydrogen bonding is stronger than London force and stronger than dipole force. So other physical properties of liquid, I want you to go through that and read it yourself. Also, I want you to read the next concept, which is 4.6, the structure and properties of the solid. This is page 268. You read all of these pages until you read all until this page, which is 272. And yeah, that's it.